Now we're angling off, so our hypotenuse is the 330. What's our resulting speed going to be like? Not exactly, but is it going to be exactly 330? More or less? It's going to be a little bit less. Why is it going to be a little bit less? Because you're kind of flying into the wind. A little bit. Not directly into it, but you are angling. Wind was from the other way, you'd end up further away from where you wanted to be. It would be faster if the wind was from the west. Because if you're flying this way and the wind takes you this way, isn't this side longer? All right. So my resulting speed is going to be a little bit less, right? How could I find my resulting speed? And now here's something else for you. In this case, is my resultant the hypotenuse? No. My resultant does not have to be the hypotenuse. I'm still adding them. Still adding vectors. But yeah, you're subtracting there, but you're not subtracting vectors. So in this case, it's going to be 330 squared minus 45 squared. Take the square root. It will give me this side. How long is that side? What is it? 327. That'd be bigger than, oh wait, 327. Sorry. Somewhere. I don't know where. Oh, I think they're back in a table back there. 327 kilometers per hour. So that's your resulting speed north. All right. So what direction should you be flying? When I ask for direction, what am I looking for? The angle. This angle in here. How could I find that angle? I could use sine, cosine, tangent, whatever I wanted to. So that angle is it going to be a very big angle? No, it's going to be pretty small, right? Because this side is small compared to that one. What is it? About 8 degrees. East of north. Now, you're an airplane pilot again. You've got your 2 hours worth of fuel. Your destination is 660 kilometers north. How's your flight end this time? After 2 hours, where are you? ...354 kilometers from where you started. How did I get that? Or not 354, 654. Because my resulting speed is that's how fast I'm going to end up traveling. 327 kilometers per hour straight north. After 2 hours, when I run out of fuel, I'm 654 kilometers from where I started. I'm 6 kilometers short of the airport again. Once again, I'm in a field. I've crashed my plane. Are pilots concerned about vectors? Absolutely. Absolutely, they have to be concerned about that because they have to take in all that consideration. Nowadays, they do it mostly with computers, but you have to really understand the concepts of it. Any questions on that one? I got one more example to show you. Another example. Here's a river. 125 meters wide, current of 0.5 meters per second. Tarzan can swim at 1.5 meters per second. He wants to swim directly across the river. You know who Tarzan is, right? I don't know. What direction does he have to swim, and how long does it take him to swim across there? Okay, again, we're going to draw a picture. Here's my river. Current is going that way, because that looks like down to me. Which way does a river flow? Every river in the world flows the same direction. Downstream. Every river flows downstream. Some rivers do end up flowing north, south, east. We're not concerned about that. We're just going downstream. So this is at 0.25. Tarzan can swim 1.5 meters per second. Which direction should he swim? Upstream. A little bit, right? How much upstream? Well, he's going to swim in this direction. The current's going to bring him back to that right there. This side of my triangle is 1.5 meters per second. So by asking what direction does he have to swim, I'm asking this right here. Now, does Tarzan end up swimming faster or slower than 1.5? A little bit slower. Why? Because he's swimming upstream a little bit. He's fighting the current. If he were to go downstream, he'd go faster. How could I solve for this angle right in there? Sine. Sine of my angle is opposite 0.25 over the hypotenuse of 1.5. My angle would be you'll catch on. What do you get? Well, what? About 10 degrees? Anyone else get that? We'll call it 10 degrees. So he's about 10 degrees upstream. How long does it take him? Well, it's 125 meters wide. Does he swim at 1.5 meters per second for 125 meters? No. I've got a totally separate triangle. This is a speed triangle. This has all speeds in it. My distance triangle would be 125 there. He actually swims like that. So how fast does he swim at his 125 meter distance? Right here. That speed. The speed in his direction that we're looking at. So how fast is he actually swimming is what we need to find out in order to solve that. How would we solve for how fast he's swimming? Pythagorean theorem. 1.5 squared minus 0.25 squared, take the square root. How fast is he swimming? What? 1.48? So 125 is his distance. We know that speed is distance over time. So time would be distance over speed. 125 divided by 1.48 gives you how long it takes him. $84 seconds, somewhere there, 85 seconds, something like that. Hey, Tarzan, you ever seen him? Dude's ripped. He wrestles alligators and wins. Yeah. Individually, the parts of these types of problems, you've all done before. Pythagorean theorem, sine, cosine. The thing about physics is it's an application of it. It's how you use it, how you put the pieces together. That's what's going to be the tougher part, right? And the only way to do it, practice, 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 practice. Upstream. All right. Work on your other problems. This is Chapter 5. Chapter 5 worksheet will be out tomorrow.